Hello everyone. This is the 13th part of me making a 4K intro, and today I'm going to start working on sound for the intro. So basically, I guess I should have started with the image that we have today. And this doesn't look like it, yeah. Huh? Interesting, okay. Uh, yeah, I see. That's the problem here, right here. Last time we haven't we changed a bunch of files, and names of the files are wrong. So it's race. Yeah, it's now Ray March. And yeah, that's it. So this is the image that we have currently right now. This is basically geometry, post-processing, and shading test, and camera movements are from the older intro that I wrote, and that basically I made visuals for. And yeah, this is work in progress. So today we are starting working on audio, and for that I will need to add a sound output and MIDI input for the tool. And this is what I will be working on today. This will be a rather boring stream because we won't make any like cool sounds or whatever. We will just lay the groundwork for the sound even to be possible to input and output. But I will in the end I will tell we will discuss architecture for the synthesizers that I want to be in this intro. So that for the technology, as my main development platform is Linux, I will be using Linux sound APIs for the tool. So basically this tool right now doesn't work on Windows, it's very Linux specific. Maybe at some point I will port it to Windows, but currently it just will, like, it doesn't make sense for me to spend time on that. So, for the Linux part, I think so. Basically, in Linux, there are too many sound APIs to work with. There is basically there are ALSA, which is the basic like this is the main API to work with sound in terms of sound hardware. So ALSA is basically user space something plus drivers. It's rather low level. And basically it requires some setup to even like allow multiple applications to work with the same sound card at a time. So like 10 or 15 years ago for on Linux, you by default you had only one application working with the sound card, and if you wanted to have another application to work with it, it's either you needed to close the first one and open another, or like write this special also configuration file which allowed for multiple applications to work with it. And like okay, this wasn't pretty. Then another thing here is open sound system, which is like outdated and isn't used anymore. Uh, that like what maybe someone still uses it. Like this is actually, I think this is the best API because it like you open a dev DSP file and like write samples to it. And this is basically the API you had. You had a bunch of IO CTLs for like format and stuff. And this is like the really lightweightest and the best API to work with. It's really simple, but for some reason it's like being phased out. And yeah, I think there were some license issues, but anyway, this is not the point. Like this is not, we can't use it. It's outdated. Nobody supports it right now, and yeah. And the current main API for the sound on Linux is Pulse Audio. This is basically a daemon that starts with user logging into his desktop environment, and it manages all the stuff like multiple sound cards and multiple application. It can route sound for like yeah, you can do a lot of stuff. It can pipe your audio through network to another machine. It can like switch the output in real time, so you can your application can basically it doesn't even need to know like what output it has. It like set up its audio, its sample format, sample rate, and stuff like that, and writes samples to whatever, and you can switch sound cards. You can you can switch from your hardware sound card to network output in real time, and it will basically work. The downside of it is like I spent 40, I think, minutes just before the stream to get the sound working in these separate streaming users that I have, because of, I don't know, because Pulse Audio for some reason I've run a Pulse Audio server for another user right now, and this new user just won't see the main sound card. I don't know. This is like, yeah. So basically, I tried to do it the supposed way, like console kit demos or whatever, and it didn't work, and I just had to kill it, and then I had to relog in a couple of times because yeah, it's broken. So yeah, Linux is bad. Don't use Linux. Hello Telefon, Николай Фадеев, привет. And for actually the best API, like after open sound system, the best API, the most convenient API to use with sound is Jack. This is the best. It's really simple. You just open the client and it like always have float point samples. You just the purpose of this API is to work with sound software, internal like music making software. It allows you to route applications into one another. It provides a real time. It hides all the like real time issues. So if you initialize Jack API, you set up a callback for Jack to call to when it wants to give you new samples and take samples from you. And this callback runs in a separate real-time context, so you don't have to set up anything. It basically just works, and you just have to be really careful to not use any like locking stuff in there. So basically you can't make this real-time thread wait on anything. So mutexes are not allowed, and most of the system calls are not allowed also because they will just make they can stall your real-time thread, and it will basically break a lot of things. Yeah. uh, I really love Jake API, but the downside is that you have to run a special Jack daemon to manage all the Jack stuff, and usually it's okay. But Jack doesn't really work that great with Pulse Audio. There's a bunch of shell scripts that just stop Pulse Audio, free the sound card, and allow the Jack to pick up the sound card. Basically, Jack and Pulse Audio work on top of ALSA. Yeah. So, this is a short... and this one also have MIDI interface and MIDI API. And it has a couple of MIDI APIs, like raw MIDI, which is just allows to get a raw MIDI packets, and sequencer, which allows like some routing between application and something like that. Pulse Audio doesn't have any MIDI whatsoever. Jack has both sound and MIDI, and it also like has some routing of MIDI messages between application. Yeah. So the main purpose behind Jack is just to allow for a music studio to work with multiple applications that has that can route sound into one into another or something like that. So I think I have a bit of thought about it, and for the tool that I write in here, I just want to... I think the best approach here would be to write an ALSA input-output for the sound, basically output for the sound, because there's no point like in reading sound from anywhere, because basically this is a soft thing that only generates audio. And also use ALSA raw MIDI to input MIDI messages from like something like this. Just yeah. So this is what I will be working today on. And yeah, another thing is that even though Pulse Audio works on top of ALSA, it inserts itself as a default ALSA output. So basically, any application which require ALSA to work, which use ALSA for sound output, they will automatically work with Pulse Audio. Yeah. And this is why I think that working with ALSA is the way to go for... And yeah, basically there's a lot of like, okay, I will just open documentation and just start working. There are a lot of ways to work with ALSA. There are like API for writing, like basically read-write calls, and then memory mapped regions, which do not work with Pulse Audio for some reason. Please read this. I want to read this. Okay. Telephone writes, so can I create a chiptune using a software like Fimi Tracker and then insert it into an intro demo? I don't know what Fimi Tracker is. I guess I can just Google it. But from the sound of it, it sounds like Famicom system. Interface. Yeah, basically, for this tracker is like a sequencer for the NES hardware, and for if you want to use it in a intro demo, there's like two ways. One way is to like just export a sound file like MP3 files or something. Then basically you can't write an intro because it will take a lot of space. And another way is to implement NAS like sound hardware emulator in your intro. I don't have any idea whether how difficult that might be. So basically, if your NES hardware emulator runtime can be made small, you can use something like that. But usually people just use regular trackers. Like, there's a lot of them. Like anything that can output XM or IT formats. And use small samples or use just strip all the sample data and then auto-generate it on, like synthesize it with some functions in intro. Not sometimes in real time, sometimes in like pre-calculate. So there's a lot of options. You can do like try to emulate the not the entire NES hardware, but just samples that you want, just something like that. If you understand what I'm saying. So I need to open also API. I said, yeah, this will be really boring. Yeah, PCM digital audio interface. We'll start with this. We'll need to like send a PCM open or something. Boring stuff. Yeah, so which file will need to include? Okay, let's just start writing and we'll figure this out. So main. Yeah, this is basically we'll write an a simple tool just to test the API, and then we'll integrate it into the tool that we use for the intro development. No point in any arguments. So this will just have a PCMT handle, PCMT also red the PCM open, and this is a pointer, right? This was a pointer to pointer, and then we need to like the name is default. We use only default sound. PCM stream T. What is this? Okay, they had a little example somewhere here. This minimal one. Do they have it like here? Yeah, they have this and this, and minimal one is just. Yeah, this is. Yeah, this is basically the direction. Check the direction, and mode is. Not sure what I need to do. Like, let's start with a simple blocking mode and then figure out if we need to do anything like more complicated. Set params. Okay, so need to error. Yeah, this looks okay. Right is less than 0, right? This is a check. Yeah. Then we must okay, this we have an error here, and yeah, return -1 or something. No, 1, and this will return 0. Yeah, let's write it as also sample. And it suddenly doesn't like a sound leap, and this one sound leap. Okay. Okay, include also, what do we have here? Okay. No. Lol, no. Yeah, and then we also need to yeah, PCM setup stream, and this is a large example which has a lot of sound output things, and this one PCM handle, let's call it PCM. So and there PCM set params PCM format is like what I want it to be float, but I think this won't work. We'll try that. And then access, what is access? Relieved. Channels, I think we'll be fine with mono for the time being, and then let's do it like this, the usual 44.1 kilohertz soft resample. Allow resample, I don't care. Latency required, overall latency in microseconds. What do they do here? Honestly, for this thing, I really wanted to be as low latency as possible because I will use it for development and for writing music. So I want to have an output as soon as possible when I like press MIDI keys or something. But this will work on top of Pulse Audio and on top of ALSA, and I don't know how many buffers are there and how well it's written. So okay, let's try. Um, Usually it's hard to get even when you use raw ALSA or something really real time like Jack. It's hard to be below like 5 milliseconds. Uh, let's make target like 10 milliseconds. 10, 10. Will it work? I don't know. Yeah, and if this thing doesn't work, let's do the same thing again, and I'm starting to wonder about wrapping this into some macro or something. And yeah, then for this API we just this one, if it's okay, just initialized everything and we can write. Yeah, what does this example do? Yeah, basically it's out this and this. Full configuration space. What? What does it mean? Configuration space. All possible ranges. Okay, let's read it a bit more. So they do this weird thing. Rate resample. Draw leave. Sample format. Forms channels. Here. Okay, basically it's the same, but like a little more flexible or something. Okay, I don't need that. I think this one. Start threshold. Stop. Okay, something thresholds. Allocate buffer and yeah, and then transfer loop. We speak transfer method. So the thing is that he also has a lot of transfer methods like standard IO and yeah, read write and direct like with memory, and then the interleaved and non-interleaved modes for each of these. This one doesn't work, this one works, and for this one there's like blocked and non-blocked operations. Okay, so if this is okay, then we can just pick this really simple example And yeah, so basically the idea here is just we write samples into this PCM right interleaved. Handle, buffer, frames, number of frames. So a frame is a set of samples of like if you have two channels, a frame is two samples, one for each channel. Yeah. Some errors and I will need to time that to figure out. Okay, so forever, just yeah, forever. We have we have only one channel. Can have a buffer like let's make it so 10 milliseconds. 10 milliseconds is like 100 times smaller than, so it's around this many samples. Like it's basically that many because of the sample rate, but whatever, we'll need to do it like that. And let's output a sine wave. Plot phase. Yeah, let's start here. Plot phase. We'll start with 0, and we'll have a const plot delta phase, which is so we, for example, we want 44 hertz, which is note A of some octave. Like this is a generic base frequency for a lot of stuff. So we wanted to oscillate for 100 times per second. So each. We have that many samples, and we actually need to, yeah, the phase will have a semantics of like from 0 to 1, and then we can just be okay with this one. So if we add that many times so many times per second to this one to phase, we'll basically wrap it around that many times. Yeah, and I think I will need like many other things like yesterday and also math. No. Basically buffer is a little more difficult. Сасрус, привет, звукач-музыкант прибыл, будут вопросы, постараюсь далеко не отходить. Ну, сегодня больше про такую техническую часть, про вывод звука и ввод MIDI. Думаю, сильно музыкально тут не будет. Будет вот так. Про перекладывание из пустого в порожнее. Хотя, может быть, про MIDI там начнутся какие-нибудь нотки, там 12 полутонов, ну вот это вот вся фигня. So we want to update phase like with dephase, and then also make phase like f mod, I think it was called, like no, fract phase. Do we have like this fract? Or I just too many shaders? So we have a floor, right? Yeah, we have a floor F, and we have trunk, round to integer. No, this is not it. Sail floor nearby int. Do we have a mod? Remainder. Да, корень 12 из 2 и прочая хрень. Да. So, okay, fract. Like it's floor, phase minus floor phase. Yeah, this should work. And this one, this is where we write phase. Actually, we like can't compact this as. No, we can't. It's whatever. This is like only the test. And then we will snd PCM write interleaved. PCM is the first argument. Then we have buffer. Then we have size of buffer. We write the entire buffer, and this looks like it. Yeah, we then have to do recover in case of errors. Error is true, then error is like snd PCM recover. This is for xruns and stuff like that. Xrun is handle frames 0. Xrun is when your application is unable to write samples as fast as sound card requires it. So recover does silent, do not print low printed. System call. Okay. If her is then we just like again we print an error. Recover error and return 1, and this on playback and set params error, and yeah, and this one should just like output sound. We'll close this, we don't need this anymore, so it's like blank authentic G for some reason, and like also sample, also sample, also sample. Okay, of course we need like sound and lamp. It works, but it doesn't work like yeah, of course. First thing we need like to make a sinus of it, and let us look at this one from -1 to 1. This doesn't look right, actually. Okay, let's like write a bunch of floats to the screen and figure out what's wrong. This looks like it's working, but okay, it's 100 milliseconds. No. So you basically what? Something is really wrong here. Really, really, really wrong. Такое ощущение, что сэмплы не в той последовательности вводятся. Буфер рвется. Okay, let's look at this and this function semantics again. Set params. PCM format, yeah, right. Access channels, software sample, latency. As a simple test, we might do this. We might like, okay, 16 or something. This is what is U16LE light engine. And then we can make this one not float by unsigned short. And then like, okay. Meh. No. Sample format is not available for playback. So basically you are okay with floats, but you don't like the usual 16 bits. Okay, big endend. Let's try big endend. No, it's not like, doesn't like. Like what the hell? This is the most. Signed, of course, signed. Yeah. Signed short. Yeah, right. This is weird. So, as simple thing as like just output audio is already like doesn't work. PCM rows, PCM just for the sake of it. This one looks right? Like it's okay. What the hell? Why? Maybe you like want a bigger buffer? No, you don't. Maybe you have some trouble with this. Yeah, basically by default we are in blocking mode, right? So if we do a SNDPCM open with this one set to 0 and on blocking mode no, and I think no, we just want to block, and yeah. Okay, let's look at this bigger example. Where was it? And they had the simplest right buffer size. Okay, I think I have an idea what's wrong. So these are right, it's size in frames, not in bytes. So we just need to, yeah, I'm pretty, and this is because I don't want to know what was wrong here, because actually what we do need to do is this and this, and we have only one channel, and какая-то слишком звучащая синусоида. Это this is because basically this is not a sine wave. It has some discontinuity somewhere. This is how discontinuity sounds like. Джейр пишет: о, адекват стримит в 8 утра. Я нормальный. Нормальный. This looks... of course, yeah, this was dumb. Yeah. Great. That is great. So we have, after 40 minutes, yeah, after 40. Джейр пишет, что за саундтрек? Это для Тулы делается ввод и вывод для работы со звуком. Дальше я расскажу, что за идея синта. So at this point we have sound output, the really basic sound output, and one of the things that I want to check is how low can I go on latency. Not really low. Okay, 1 millisecond is too much. 10 milliseconds. 10 milliseconds is okay. I'm fine with 10 milliseconds, I think. So and at this point I assume that I shouldn't assume anything. I should basically let's measure how often do we have a control after this function. So basically how long it takes, for how long this function take control and waits somewhere inside. Basically to figure out whether we need to do any non-blocking or synchronous operation. What was the function that won't get time or something? Get time spec, clock real time. Асрус пишет 30-50 миллисекунд ставь, не ошибешься. У меня не все работало с 10. So Sas wants me to make a 30 to 50 millisecond latency because it doesn't always work. До 100 миллисекунд почти незаметна задержка. And he says that 100 milliseconds is up to 100 milliseconds is fine, like you won't notice. This is different from my experience. Yeah, like 10 milliseconds is rather low, and it requires usually requires a special tuning to get that low. But I have problems with like 50 milliseconds is usually unacceptable for me. I notice like 20-30 milliseconds and I kind of notice it and like do start to stutter. And yeah, but we'll see. Maybe I don't think that I will like play live for the synth here that much, so it won't be a problem. But for now, I see that 10 milliseconds do work fine, and I will stick with it unless there are problems any along the way somewhere. Yeah, so I want to measure time, and it returns at time spec, and I'll need this header. This time spec seconds, yeah. Okay. Okay, you will need yesterday int, I think. I don't remember. Yeah. And I think I will wrap this function into something like 60, 40 now, time now, and this is time spec ts and clock get time tonic row and ts and return ts t seconds. I will work in microseconds here. I don't need like any nanosecond precision. So this one is time now, and this one is, well, I think I just can time now minus last. I have no idea how to use Vim. What was like this one? Here? What? What? Yeah, right. Linux. Unsigned LON is 64-bit on a 64-bit platform, but and lon is a separate type, even though it is also 64 bits. Yeah. So basically it takes from around 10 to 12 to 14 15 milliseconds. I think I am fine with that. Сасрус пишет, там еще такая телега, что при 44 100 sample rate 1 миллисекунд 441 sample, ниже будет целые числа, не знаю, насколько корректно с этим работает. Usually it's like hardware buffers are always power of 2 something, or really close to that, but usually that. So like it doesn't matter that much. So okay, I am fine with this. I don't think that at this point we'll need any asynchronous operation. And we can start to look at MIDI input. So this is okay, go away, I don't need you, a raw MIDI interface. So okay, it's raw MIDI open. What do you mean by input and output handle? Okay, maybe that means like when I want to just input or just output or both of them. Name of this handle, okay, open mode. Okay. And then I think I just need to no, I'm wrong. This one is not me. This one is the device that I want to open. So it's either I know the name of device beforehand and I can pass it as an argument, or I need to enumerate all the devices and just open everything. Yeah, and for this one to work from a single thread, I will need to do, non-blocking operations. Contested return buffer. What is this? I don't know. Isn't that raw MIDI sync? Sure, this concept of output buffer specified to the right is all drained before the function exits. Okay, so okay, flex. This one RLG copyright with return me busy. Blockchain is behind right and again no more byte can be processed. I want this flag and yeah, I want this append. I don't think I want this. Sync always drained before the function exits. This can at this point I won't use any MIDI output, so I won't need to look at this. And then on the standard ready, Yeah, so this is the only option to get like MIDI events or MIDI name and conventions. Name, virtual, physical, mix of both, generic strings, device name and arguments, device and arguments, configuration files. Okay. Default device is equal to hardware device. Okay, default this. Yeah. Насколько я понял, это все работа с железом, его же не будет. So I have this one here that I want to use for development, and the idea here is that I want to just not put the numbers into some table, the number of notes, and use knobs and sliders to control parameters. I also think that today we might also try this. Like, this will be fun. I think we can do this today. But for now, I think I would like to open MIDI interface here. Does it require another special header? No, it doesn't. I can just like listen there, raw MIDI T. Okay. This we have initialized audio, and now raw MIDI open, and this is where we actually RBC chart probably need some arguments because we will use that for MIDI device name, because I think for some reason this doesn't work. At least it didn't work for me last time I tried. This and we'll need a flag, which is raw MIDI non-block. Raw MIDI open signature. Yeah. Oh, right. Yeah, this is no, because I don't need that. And then, as always, if error is less than 0, right? The negative error code less than 0, then printf open as and star error. Yeah, and basically here I can do something like raw MIDI read buffer size if this is, I think that we just exit because, well, and although we need this char MIDI buff, this should be fine because MIDI messages are kind of short usually. And at this point we'll need to parse the MIDI messages. So MIDI messages massage summary of MIDI messages status note on note of events. Сасрус пишет, а вот с MIDI никогда в прогах буфер не видел. Я так полагал, что MIDI событие приходит и сразу на обработку попадает, потому что там скорость весня небольшая, интересно. Смысл такой, что MIDI это все равно какой-то байт-стрим, несмотря на то, что он маленький. Просто обычно это raw MIDI интерфейс, это вот сырые MIDI сообщения. Обычно их, конечно, оборачивают сразу, типа там события ноты, контролы, вот это вот вся ерунда. Еще, например, вот эти вот штуки, в них же вот это вот оно светится, и оно управляется как, не знаю, как конкретно на этом девайсе, но на подобных девайсах оно управляется тоже в виде MIDI сообщений, то есть через MIDI сообщения загонять битмап в память этой штуки, то есть там они могут такие типа сотни байт занимать, там есть проблема со скоростью, у них там двойная буферизация начинается, очень смешно. So the point here was that we do need MIDI buffer for, like, MIDI is a byte stream, and we need a MIDI buffer for some place to store the bytes. But usually for higher level interfaces, the MIDI messages are already parsed, and you just get MIDI messages in like note on off events, control events, or some and stuff like that. But here we need to parse MIDI notes by hand. And like buffers do make sense in when you need to send a lot of data, which is the case for updating status colors for control like this, where like there are a lot of buttons that can change colors. I think we will do this at some point. We will draw on these buttons sometime if we have time, and if I will like want to delve into that, because I don't think that this is documented. But for now, like, I want to just play some notes. Okay, what does it mean? Okay, just for the I will print whatever it is sending, and then I will write the code that okay, so you don't like the... Okay, you just don't like because I haven't plugged this into anything. I will need to plug it. Okay, it's here, and you still don't like it. Okay. what? Something went wrong and it didn't even tell me what. Ah, yeah, this went. Yeah, and what was the semantics of this function? What do return values mean? Open. What does it do here? Device in, open, handle in, device in. What? No, I didn't. This is something else. Second handler. Have no idea why they do that. Probably just to avoid interrupts. Ah, no, this is because they use the Control C as a like graceful method to return. I just don't care. Just stop, kill my process, and I'm fine with it. Read. They read single bytes. Okay, let's try just not doing anything. Like, okay, let's just print the code here like that, so it will be buffered. I think I will want to make this a little bit quiet. -11, and this I want really to be like this. -11 is something. For some reason, their example doesn't even check for errors. Like, they don't care. Yeah, they basically don't care, and why should I? No, I need the output, but I don't need this. And if it's larger than the 0, then like maybe if this is less than 0 and r is not equal to maybe that. Because I do want to know if something went wrong. MIDI read s stir s and stir error return 1. Yeah. Well, you see how many messages there can be at once, at one read. So, yeah, this can happen. So the first one is 9 is note on, 8 is note off. Second number is note number, and third number is we have another one, right? Cool. Third number is velocity, which is basically the like how hard did have I pressed the key. A MIDI channel number. Okay, so yeah. So basically, for the start of MIDI message, we do if MIDI above 0, I think this should be actually larger than 2 minus 3. So we'll parse only these messages, and if not like that. Okay, channel is MIDI above 0, this, and then we switch the first byte with note on, note off. This I have no idea. This okay, control change. Basically, I care about this message, and this message. Okay, so case and case this is note on and off events, and this one will be 11. No, 3 and yes, 11. It's C, B. Note on is 9. So this one I don't currently care about. And this is where I removed cons from the phase and basically base it. The phase is still the same bass frequency, but now I want it to make relative to multiplied by so note number is the second byte, and for the bass let's be this 48. I don't know actually what it usually is. I just take this and Yeah, this probably should work. And for these control messages, I don't care. I still want to output the code in case something goes that unexpected, and you don't channel. I don't need any channel whatsoever. So okay, we have a basic output, MIDI input and audio output. Now it's time to use this in tool. Nice. So for the tool, I really want to have a simple as possible API for this. And the simplest API that I can think of is basically Sasser пишет либо 57, либо 69. So why 57 or 69? Why? What is the reasoning before? Okay, let's do 57. Yeah, this sounds right. This sounds right. Okay, so for the intro, what I need to... Random Trash пишет, насколько я помню, 440 это 0 ля на гитаре. Да, 440 это ля какой-то там октавы. Я тоже не помню октав. Плюс-минус октава, я думаю, вообще все равно. Главное, даже в этих целях, в общем, можно промазать там и на ноту. Но... Допустим. Okay, so, simplest API. Simplest API. So let's audio callback is something user data, and then float some samples, and then int and samples. This is interesting. This is basically I always forget how do you type def functions. Like for some reason it's really like always function pointer. Yeah, this is really silly. So, yeah, and then yeah, I always forget. Like this. And yeah, I use like this convention. And for the MIDI callback function. Okay, 69 it is. I don't care. The thing is I actually don't know what my MIDI keyboard is based on, and there are some like octave up and down keys that really mess octaves up, and like this won't be consistent at all. And for the MIDI callback, this is const and char data bytes. It's interesting where to draw the line, because I can parse MIDI messages on the like level on this API level, or I can pass this task to the caller, and then like just to initialize I can do like int audio open and then something like void user data, which will be passed to this, and then basically audio callback and MIDI callback, and that's it. Well, I can also do like audio flows. Do I need to do something like start and stop? I don't think so. So this is the API. Let's write this as a header only library, because why not? So it's always like pragma once. And then if defined audio implement, I will want to make this a part of Atto library at some point, so I will just start forming it in that way. This one I really want to make. Okay. Yeah, this makes more sense. And then if defined, then I will need this. And implement this. yeah, basically this is the API for the audio output MIDI input. And then I want to make a static struct audio, which will store all the state. And this will also store this state. Okay, it will always open. And here lies a problem, because I want to микрофон бум. Микрофон? Или я его задел случайно? Простите. So sorry for the mic. Okay, so API. One thing that I didn't think of is a list of MIDI input devices. And honestly, it would seem like MIDI should be a thing of itself. So is this better? Okay, great. So one thing is to open audio output default one, and another thing is to open MIDI device for input and output. For now it's only input. So I think I will separate these. This one really simple, open, close, and like callback, and this one is MIDI open void user data. The problem here is that I really want them to be in one thread, but like at this point it gets complicated, and okay, for current purposes I will do it like this. Device, I will only support one device, and I will like have these go together. And sometime in the future I will figure out how to properly handle it. So this one will be always MIDI, and it will open CM and MIDI. Okay, let's separate some errors like -2, -3. And then this one should actually be a separate thread, so we will need threads. So at this point we have everything initialized, and we will just need to the thread open create. Like create thread. No attributes whatsoever. Start fetching audio. Thread. And argument is nothing. And audio thread is nothing. We don't use that for now. Well, we can pass user data here, but yeah, okay. Okay, user data will be passed right here. And then we can have these this entire thing here. I forgot to copy that. And then we don't need this. We need this and this. Maybe I want to make it a little bit. Okay. I probably need to specify that buffer audio buffer size like this, and MIDI buffer size like this. I said that this stream will be really boring. And sequence of events here is like this. We first check for MIDI messages and then pass them to the caller audio MCB data MIDI buffer and bytes, and this one we don't need here. And this one we will need to do in the tool. And then we do this. We call audio callback with data buffer audio buffer size, and then yeah. And audio close is actually nothing, because, well, because it will need a separate thing to one is a success. This will probably break a lot of things. Okay, so the tool. It's on page 1. Audio and implement. And somewhere here we need to make callbacks. Static. Yeah, this one and this one. And yeah, we need thread TS thread. And also we like to do your reach. Yeah. Okay, ECB, ACB, and audio MCB, MCB. Yeah. Callback and yeah, static void MIDI callback. Why? Boring stream is boring. So basically I want to do the same thing I was doing there, just for the test. And then when it works, I will add some MIDI controls for the graphics scene, and we will like try how it looks like and how it behaves. And how cool is that? Okay, static float on the face. Yeah, and we need actually to initialize audio API here. Open and null. And here we need audio callback. And MIDI device. And MIDI device is default and this device. But then we need to start the tool with additional argument always. And this one will be basically a straight copy from here. Yeah, we'll need to copy this one. No. Yes. This and samples. And this is samples. And this is phase, which is 0 by default. And for the MIDI callback, this. Basically, it's always true. Data, and it's not error, it's bytes. Yeah. And there's a small mistake here, is like data should also +3, and yeah, MIDI buff is data. And here too, just for the sake of it. Okay, so this should work. Yeah, of course, yeah. This is stupid. And what else is stupid is line 67 here, yeah. This is stupid, and line 84 is stupid for some reason. Because you need to, yeah, this need to be at least that, and then yes, this line is also stupid. This is like, why? Okay, not shader tool, sound, math, and all the thread. And then I need to, this one, this like, well, yeah, it didn't open MIDI because I didn't pass it. Yeah, and now I can do this. Okay, so basically this works. And what I need to do is to commit it right now and do something interesting with it. We'll need this, and we will need this. Okay. also sound output and MIDI input to the tool. And now I want to do, so basically we are halfway there. We have added audio output and MIDI input for the tool, and what I want to do here is to add some MIDI controls to the graphics. So we do have timeline. I think that I will add this really weird thing here. Can I like MIDI or overwrite MIDI? Need retro is basically time adjusted and all this crap. So I think that at some point I need to add more natural inputs. Where do I add stuff? Okay, let's do it this way. MIDI, 4 of them, just as a test. And this actually I want to be 4, and I will be making all of those 3 ones 4 also. There's a way like to pass a 4FV and passes as a single pointer. Yeah. So this one, and then the control, and this is a control, and this is value. And this now is no, this is, can I run this? Yeah. So this control 30, 34, 30, 31, 32, 33, 34, 35, 36, 37. Okay, so this to have on my keyboard offset of 30, which is like hex 30. And also I will need to get rid of audio because it doesn't make any sense now. Where are the audio callbacks? Let's do this. Yeah, output zeros. And here we will open audio with intro get. And in MIDI callback, what we'll do is cast this. I think this just works as static cast. User data. And here, yeah, MIDI control, and the control is like second byte, data 1 minus 30, data 2 is the value. And here I can just, if CTL is larger and still smaller than 4, I can just do this. Still equal to value now I have a separate control for something. Will it build? Yeah, it will. Okay, so now we have this. It doesn't sound like anything. And now I can do, what I can do is to go to shader, ray march, for example, add a uniform vec4 M. Do we have any more M's here? No, we don't. And start to like, okay, I want to, what I want to do. Ah, I see. Yeah, of course. This is because yeah, I need to stop that. And for some reason the window still. Okay, whatever. Basically, I don't do redraw when MIDI bool MIDI change it. This is bad. This function gets called from the audio thread, and we get these values from from the main rendering thread. Major draw is not post. He changed. This may or may not work based on some okay, it doesn't work. Why? Of course, because the 30 is not actually 30. Because this is like this. And then no? Still doesn't work. Okay, let's just print whatever it says. So this one should work. This one, I print. GL value. So this actually don't get called at all. For some reason. Like maybe yeah, maybe I'm... This is stupid. Okay, I can't control something with my MIDI controller. Great. Then I can do... What else can I control? I can still do like things like this. Yeah, like control this. I can control colors. So I can control this. I can control... Oh, great. For example, yeah, I can control colors. Which object is this? Okay, this is completely bogus. This like something else. Okay, what else can I do? This is DZ plus 10, not 10, like, okay, 10, not even DZ, 10 MW and then focus. Focus. Uniform vec for M. And then I can just rotating a knob make a focus on any distance I want. This is so cool. Okay, so this is just a test. I don't think that it's feasible to do it like this, just adding all random variables at random places. This should work some another way. I will have to think about how exactly it should work. And yeah, so to the third part of the stream, it's already 2 hours. Okay, just a little bit of I won't go in any details. I will just tell you the basic thing that I want to make, and next time we'll work toward that. So basically what I want to do is to make an automation. There's several points. Like point number 1 is I want to make a single automation slash sequencer, which will control both audio. Okay, this is and video. So this is a single source of events which will output some signals controlling audio and some like envelopes controlling video, which will be based on really like same things. The idea here is to try to have basically good synchronizations, because they are fed the same data, and size optimizations, because basically there's the same data used for both, and I don't need to have a separate sequencer for audio and separate like timeline data for video that like I had in web. I'm not sure still that this is a good idea, but I will have to try to understand whether it works as expected. This is one thing. Also, another thing is, I will have to go into details by why I think that will work. Anyway, this is like point 1. Point 2 is I really want to make audio programmable. So, like modular synthesis, like you connect modules and something like that. But this is a step further. So audio model is like a DSP core with some code running on it. So for example, if I have an instrument, the instrument is a series of inputs. It has some signals which are controlled from the sequencer and automation. Like they go here. Signals are distinguishable for usual audio signals, so there may be some other module before that, and so there's nothing that makes instrument a separate thing from other modules. It's just the way it is. It expects its input to work, and the way the input is fed into it, basically. So yeah, from the standpoint of a final engine, this is actually an assembly code. There's no like virtual machine or something there. This is basically will be the x87, I think, assembly. And yeah, and this output that has output signal. It may have several outputs, but yeah, whatever. It's like pointer to arrays. Pointer to const arrays, pointer to non-const arrays, yeah. And this is some code that it works on this data. And another thing is like usually modules in other audio engines work on things called frames, windows, or something, which is basically a series of samples. For again, universalness of this thing, I will want to work it on a single frame per single call. This is not optimal from the point of performance, but for our purposes that should be fine. Such things even work fine on Raspberry Pi type of hardware, class of hardware. I tried that. This is one thing. So basically I will want to live code this DSP cores live, and the general architecture of the sound, what I want to see is like there's several instances of one type of instrument to have polyphony. So the polyphony is not like some quality of instruments, it's basically several types of the same instruments, several instances of the same instruments that are fed with its own signals, and the polyphony is gained by, well, this running in parallel. So in tool, there will be some block which basically chooses the instrument instance that is not running currently from its standpoint, and it will basically multiplex them or something like that, and this will just sum its signals to output. And this basically, there are several such blocks. In final intro, this is there will be no notion of polyphony, that just as many instances as required, and this basically a giant sequencer that this all will be flat, if you know what it means. So there's several instruments, and then there's all the signals from all instruments. For each instrument, I think there'll be some post-processing, like also DSP core. So this is core, this is core, this is core. These cores are really simple, basic, small, and and something like general effects that are applied to every instrument there, and basically then it is output. Yeah. Something like that. So what I want to be able to do is to program these cores to live code them. Probably not edit structure live. This may be difficult to implement like live on stream in reasonable amount of time, but live coding should be fine, I think. Then there's notion of effects which require buffers, like delay, reverb, flanger, some types of filters and stuff like that. I will have to think how I will want to implement them. Maybe this is like a single not an instruction, but like a data structure that I declare in DSP core that give me an access to a buffer, and I can read and write it from the code here. Something like that. Yeah, and also this will need to be a third point. I want to be able to control it from MIDI, this and this. So basically, and also have a like weird controls here, like camera controller. JR пишет сложный график. Прости. Ну, я плохо рисую. So, this is what I want to make. This is 3 points that I want to implement and to have it in my final intro. Fourth point, I believe that this one is for the final intro too. This one basically for this type of thing is for the development, for the tool, and final intro won't have this one as like structure. This will be hard-coded in assembly for the size purposes. I think, I expect that I will need to do that. And yeah, so this is it. So I think this will be it for today. Our next stream will be probably Wednesday or Thursday, and it will be in Russian. It will be in Novosibirsk evening. Yeah, I will announce it later. So thank you who are on the stream, and hi to anyone who's watching in record form, and I will see you in a few days. Thank you. Bye.